Hi, I'm Nick Johnson. I'm a computer science major, a sophomore at Milwaukee School of Engineering, where I enjoy studying AI and cryptography. I got started back in 11th grade, so probably 3 years ago. One of my teachers knew that I was good at programming, but the classes at my school weren't at that level, and so he pushed me to join a club where that's what we did. It was not necessarily just competitive programming, but Business Professionals of America had a wide range of things. And so starting there, it was the Java programming competition, where we got 2 problems in an hour and 30 minutes, and you had to try to solve them. And I wasn't super excited about it. It wasn't like this is a great, fantastic thing like I think it is now. But kind of one of those things where it's like, high school, whatever. And then, so junior year, I got sick and I just decided, well, I've missed enough school, I don't need to go. And then senior year was kind of like my fun run through that, where I took first at regionals and in-state. And then moving to nationals, I took 4th place at nationals. I was kind of like, this is really cool. This is awesome. That's really when I imagine like I really got excited about it for the first time, is when I was able to build it up and have that great fun run. So what I like about competitive programming is the challenge that it gives to me every day. There's always something new to learn. There is always something that I can try, whether it's a new algorithm, a new data structure. Maybe it's the same algorithm performed a different way because there are so many ways to do things, and it might be better for this problem or that problem. And trying to find that challenge in my life when I'm always trying to do something so that I have a goal. I've got that next step. Competitive programming is a very easy, logical step there, because I'm never actually done with it. I'll say I'm always taking that step where I can get better somehow, and that's truly something that's very exciting about it. I would say it definitely helps in both, and I'll come up with 2 different examples. So in our studies, we often have teachers who prepare labs, and of course they'll make solutions for them so that when we're done with our solutions, we can make sure that they work and everything. And we were doing a lab on word recognition. So it was a deep learning lab, but we were using Python at that point to process lists of words. And my knowledge of data structures and analytical skills that I've gained through competitive programming allowed me to create an O of n algorithm for something which the professor and most other students came up with an O of n cubed. And when you're processing hundreds of thousands of words, that's the difference between 30 minutes and 3 seconds. And that's something I've found to be widely applicable just in school in general, where there's usually something that I can pull out of the top of my head, which allows me to either get a lab done incredibly quickly or help my fellow students learn something new. And in my personal projects, I've always enjoyed trying to create tools which help other people do their things easily. And so one of my favorite projects to work on in my free time is a Kotlin graphics organization, where we create tools to help people use OpenGL, Vulkan, and other graphical tools in Kotlin. And one of the things in there is the general optimization of competitive programming, where I'm able to look at these code paths and figure out how can I best do these tools so that I can, say, take some really bad graphics API like JavaFX and start translating some calls over it so that people can get cool graphics without the need for anything native installed. And it has helped me greatly in those cases. At this point, I really do not. One of the things that I'll say about me getting excited about competitive programming is, even though it was kind of like I slowly got more and more excited over the years, I never was really like, oh man, this is super cool, really awesome, up until I arrived at the North American Championship, and I really realized it wasn't just like, at our regionals, our department wouldn't cover like the $35 fee. And then, we make it to regionals, and then all of a sudden you've got this crazy, like, everyone is going incredibly hard. You've got people who are constantly doing competitions. like once 5 hours every other day, and we like would do one every Sunday. And so I haven't really learned enough, and I haven't been in the scene long enough to look at someone and go, that's who I really aspire to be like. But I've definitely been able to draw a lot of inspiration from teams who are at our or higher than our level now and are the goal of where we want to be. Definitely. So we went from before the NAC, we were kind of doing 7 to 10 hours of study a week as a group, and then we'd do some on our own, where we'd run one competition and then do some studying. But now it's one of those things where we've seen these top teams are doing 2 to 3, 3 or 4 competitions a week. So that's 15 to 20 hours set aside. And on top of that, they're doing stuff on their own. And we're seeing, okay, if we want to be a top team, this is what we need to do. And our goal is to, this year we took 5th at regionals and 45th at, the national championship. We want to take 1st at regionals, and we want to be top 10 at the nationals. And if we want to step to that level, we're definitely going to, these teams, MIT, University of Illinois, Georgia Institute of Technology, we need to step up to their level and start performing like that. It's very inspiring to be around that. So I use Kotlin for a mix of its incredible ease of use, and then I think the main reason why anyone chooses a language is familiarity. So typing in Kotlin is just, compared to Java, it's so much easier. Looking at snippets, if you want to do fast input and output, Kotlin, you can do it with just val br equals system.in.bufferedReader. And the extension functions that it has, provided with the need for no explicit typing, the compiler will figure it out, mean that compared to Java, where you have to do bufferedReader, br equals new bufferedReader, new input stream reader, system.in, it gets repetitive very quickly. And so comparing to Java right now, because that's a good reference point, I'll say, it's also one of those things where we can get what we want to get done quicker. Because there are methods like string.toInt, we don't need to be, it's kind of like you can speak a sentence out loud and put it down into code. I want to read in an integer, multiply it by 5, map it to a double, and subtract 3.5, or whatever. And in Kotlin, that's very intuitive because of all the things we can do. We don't need to be thinking about, okay, where do these object-oriented calls need to go so that we can have the right object in the right place at the right time. Instead, we can just do each one step by step with functional programming. And additionally, it's got these great tools where the language is just built to be easy to use. You've got things like pairs, triples, and so in Java, where you have to make a custom class if you want to return more than one item, in Kotlin, we can just create pairs or triples, or even return a list and then use the destructuring operator to get them all out and keep everything very organized and easy to use in a straight down manner so that we can go as we think instead of having to design around what we want to do and then go. So it's just a much more intuitive process, I would say. I would say for me, I was surprised at how I don't know if I would call it a steep learning curve. You can definitely jump to Kotlin from Java, but it will take some figuring out. However, it's one of those things where there's just so much utility everywhere in Kotlin, where you start looking at how you create an int array compared to how you do it in Java. And initializing it, you don't need a for loop. You can just put the bit of code that you would put in the for loop inside that array initializer. And with all this stuff, you can just call set of or mutable set of, sorted list of, and all of these wonderful things where instead of having to worry about creating objects and then pushing objects into them, we can just create an object as we want. We can create a map with a bunch of pairs, which is useful for, say, if we want to check if we're mapping strings to other strings, and then we can just do, A to B, C to D, rather than having to do map.put and all these things where it's just extra steps. And then additionally, one of the things that was really hard for me to grasp at first was how easy it is to use things like maps and lists. the whole thing of you use brackets, more like Python, where you've got the brackets where you access rather than map.get key, it's just map bracket key close bracket. And that whole kind of intuitive just works thing is something that I'm always, I mean, now that I've used it, I gripe very hard when I go back to Java, like, come on, you're making me use this? But getting started, it's just crazy to wrap your head around that a programming language can be so intuitive and work to your hands. I would say anything that requires manipulating a lot of data in lists is very useful to Kotlin. Kotlin is very useful to those, sorry. One of the reasons I say that is because Kotlin it's a great functional language. So rather than the object-oriented where we need to do a step-by-step or look at each individual object and do our for loops or whatever, I can just do list.map.drop last while, so I can remove the last however many elements based on a condition and all these things where it's just thinking logically straight down. And so anything where we took copious amounts of data in and had to manipulate it in some way was directly benefited by it. And coming into the North American Championship, there was one problem which we solved, which was the easiest problem B, mini battleship, where there are a bunch of small battleship pieces. And one of the most useful things we can do is with lists, we can take the first element with dot first, and then get a copy of the list minus the first element with dot drop one. And so rather than making recursive functions where we're keeping track of indices and other things, we can return pairs so we can keep track of how many states work and what kind of, and any other information we need to while using those functional methods on the lists to modify the data as we pass it through. And so for anything list-based, array-based, map-based, I would say Kotlin has incredibly strong. Too many to use, so I'll go with the two that I most regularly use. So the one that I would say I'll use the first most is the destructuring operator. Very often we have to read in a line of input, split it on the spaces or whatever, and then map it to integers. And then we want to get out the first three elements. And so it's very easy, whereas in Java, we might have to make it into a list and then pull each item out. In Kotlin, we can just do val open parentheses a comma b comma c equals readline dot split dot map string to int, and it'll take the first three items and put them in a, b, and c. And so not having to think, just being able to name my variables what I want them, get them out, and keep programming, it just keeps things moving very smoothly. And then the other one is sequences. So this once again speaks to the list area of where Kotlin is strong, but a sequence is basically a list where rather than modifying all the data in the first list when we map it, and then modifying all the data in the second list when we map it again, we perform on each element exactly once. So if we need to find something in a list that matches a condition, we might only need to go through 3 elements of mapping rather than go through the whole list of mapping 2 operations before finding it. And so those two things together are, I mean, between the speed trade-off of typing and the speed trade-off of when you're actually running code, those two features are probably my favorite. So compared to Java, I like to compare Java versus Kotlin of tying chains to your feet for fun with Java, because it's truly just so limiting once you've gone to Kotlin. The extra code you need to type, the extra things you need to do to map or transform data. You can have a Java solution that's easily 2 times longer than an equivalent Kotlin solution, and you're not really getting any runtime benefits. Your lines are 3 times as long because of all the explicit typing of things you need to do. Buffered reader versus just val, and a whole bunch of stuff. You need to make sure you're throwing exceptions and just going through, whereas in Kotlin, that's just so much more intuitive that, considering you're getting the same underlying features plus more, I don't see why anyone would use Java once they've tried Kotlin. Against C++, we can't necessarily anymore say we have the speed advantage, but looking at ICPC, the idea is that it's an algorithms contest and that there will always be a solution in Java as well. And so what that means is that Kotlin, sure, will also always have a solution. And so what we need to look at more is how does it make it easier to program? And Kotlin makes it easier to program than C++ because we can do things like these functional things. We can just perform operations on lists. We can look at the first item. We can just create a set of things or do a copy. The ideas are infinite. If you just go into an IDE, create an array or a list, and then press dot, and you look at all the possibilities on it. These are things that you need to type out 3 or 4 lines of code for C++. And sure, that's not terrible, but when you can just hit dot, find what you're looking for, or know what you're looking for, and use it, and then get your code done, it's incredibly liberating. Just you don't have to think about what you need to do. You just have to know what you have to do, and then I let the language take care of the rest, so I can spend my time thinking about the actual problem. And Python, one thing I would say is that on Python we're starting to look at something that's definitely a lot more like Kotlin when programming. We've got the indexing with brackets. We've got the ease of use where you don't need to set a lot of stuff up. But we can start looking at things like the standard library, where Kotlin offers a lot more than Python does, and it does a lot of it better. Python has a lot of those things. You can do functional programming, but it's a bit slower. You need to explicitly type things out, and it's really only easy to do one thing at a time. And other things like that, where Python and Kotlin might be about the same to type out, but in the end, you are getting some more options when you're using Kotlin, and then on top of it, the speed difference can be simply incredible. We've had solutions where our teammates wrote them in Python and timed out, and we can solve it in 0.1 seconds just because that's the nature of the language. And so if you're looking at the same comfort level, but that massive timing difference, I would say it's time to look at changing. So I would say that there are an incredible amount of resources out there for you to start learning Kotlin and competitive programming. JetBrains puts on Kotlin Heroes competitions on Codeforces, which are a lot of fun, and they're incredibly useful, I guess I'll say, to start learning. If you go back and look at the past editorials, you can start to see a lot of the things that make Kotlin very useful in competitive programming, where we're using functions inside function bodies, which make it incredibly easy to, keep track of states, that we don't have to pass in 5 variables every time we, say, add an answer to our list or something. And additionally, just try to move your old solutions over. One of the things you can do in Kotlin is basically just, if you're doing something where you're modifying any sort of data, doesn't matter what it is, put a dot after it and look at what IntelliJ suggests for auto-completion. If you scroll through, which will take a solid minute, chances are you can find what you're looking to do without doing a lot of the things that you're doing in code. Sorting is an operation built into lists. You can choose a custom sort by. You can copy to other lists or mutate certain parts of the data. And looking at those things, you'll quickly find out that there is so much you can do, but it'll take a while to get your head wrapped around just everything. I still find new things in Kotlin, and I've been using it for 3 years at this point, but I still find new things that are like, man, this is incredible. I wish I'd known about this a couple months ago. And that's just the bonus of having a language where the team is looking to make programming as easy as possible. I do use early access builds, and as well as try to keep on top of the Kotlin release train. 1.3.70 was released yesterday or 2 days ago, but I already started on the train with that, getting used to the new things where, there's always new things being added. In this case, it was a bunch of stuff where maybe this one it was more compiler related, but in this case, they also added array dequeues. So if you're looking to do something like processing some sort of graph traversal in a breadth first search, you've got that now in the standard library. building on String Builder so that there's more operations in String Builder everywhere. And everything else, Kotlin never stops. Just truly great. So our plans are, we're trying to shoot high here. Our goal for next year is to make it first at regionals, and we want to make top 10 at the North American Championship and make it to Worlds. We're very lucky to be a group of sophomores, so that's second year in college. And so we've got 2 more years under our belts where we can perform well, take this great experience we've had, and go there. And so then, of course, our goal senior year is to take first place at Worlds, which is a very lofty goal, but I've got a team that's capable of doing it. And now that we know what we need to do, I hope that we can get there. But on top of other things, it's stuff like Code Forces is great. Keep using Code Forces to build our individual skills and climb up the ranks on there, as well as other competitions. IEEE is a great one if people are looking for fun competitions where it's open to the entire world, 24 hours long, and our goal is we got top 10% this year, but we want to get like top 25. We want to be up there, and we're really looking to step up our game for next year. That's a tough problem because there's a lot of stuff that I really enjoy doing, where I'm working a lot with graphics to bring graphics to the Kotlin and Java communities so that people can have an easier time using them and things are less error prone. But I also really enjoy getting kids involved in programming. And so I think my favorite thing that I'm doing right now is we're building a module. So there's a bridge in Milwaukee where I go to school called the Hone Bridge, and it's the largest bridge in Milwaukee, where they're putting up a couple million lights along the edge, and we'll be making software so that kids can program patterns onto the bridge so that based on time, things will change in an artistic pattern and hopefully get kids excited in programming. I think that's truly one of the best things that I can do, is get other people really excited in programming so that they're just as excited to go to, college and learn about everything that they can every day. Do as many projects as they can, just like I am. I think that's, for now, that's truly something that I'm very glad to be in.